last lecture we have completed with terminology of IC engine. In today's session we will see 4-stroke petrol engine, 4-stroke diesel engine, and even we will try to see comparison between both of them. This is Faizan Kagbi and I welcome you all to our lecture series of basic mechanical engineering. So let's begin with our topic. 4-stroke petrol engine. Okay. Now as you can see, the construction of 4-stroke petrol engine is already displayed. So it consists of inlet valve, exhaust valve as we have already discussed, then piston, cylinder arrangement in which piston is going to perform a linear motion, connecting rod is connected with the piston, connecting rod other end is connected with the crank by means of a crank pin, and in a downward side there is a crankshaft to which crank is connected. It is a rotating motion will be performed by a crankshaft. So let's begin with our basic introduction. So Otto cycle was developed by German engineers Nicholas Otto in the year 1862. Otto cycle consists of 4 strokes, that is first stroke will be a suction stroke, compression stroke will be a second one, third one power stroke, and fourth one will be exhaust stroke. In this 4-stroke, crankshaft is going to perform 2 revolutions. That is, if we consider a case when a piston is at its top dead center position, at that time crank will be completely vertical, along with that connecting rod will also be vertical, as you can see in a diagram. Okay, when it is going to move from a TDC towards the BDC side, so at that time crank will perform 180-degree rotation. That is, will move in this form, connecting rod will come in a downward direction, and finally again at a bottom side position crank will be totally vertical, along with that connecting rod will be straight, and at that time piston will be at its BDC position, which means we can say that in one stroke crank is going to move from its 0-degree position to 180-degree position. That is, half revolution will be performed. In a second stroke, that is our compression stroke, in which piston will move from BDC to TDC. At that time crank will move from its 180-degree position to again a 0-degree position. Okay, so second half revolution will be performed, which means we can say in 2 stroke 1 revolution has been completed. Then another stroke, that will be a power stroke. Again in a power stroke piston will move from its TDC side towards the BDC side. Crank will move from its top side, that is from 0-degree to 180-degree, right? And then in the last exhaust stroke again crank will move from its 180-degree to back to a 0-degree position, in which piston will move from its BDC to TDC, and that stroke will be our exhaust stroke. Okay, so let's begin. Let's understand the stroke. So the first stroke, as you can see on the screen, during a suction stroke piston will move from its top dead center towards the bottom dead center. At that time inlet valve will open due to a cam mechanism. Pressure difference will be established inside a cylinder. Because of a downward motion, partial vacuum will be generated, and due to a pressure difference, air and petrol mixture will begin to enter into a cylinder till piston reaches its PDC position. And at that time we can say that crank will have completed its half revolution. Okay, so one stroke has been completed. Now let's see our next stroke, that is our compression stroke. In this stroke piston will move from its BDC position towards the TDC position. At that time whatever air and petrol mixture has been sucked will now be compressed during upward motion. Pressure and temperature of air petrol mixture will increase. At that time crank will move from its 180 position to a 0-degree position. And remember, both the valves are going to remain closed, that is inlet valve and exhaust valve will be completely closed. Okay, at the end of this stroke the mixture will be present in a clearance volume and will be ignited by means of a spark plug which is provided on a cylinder head. Okay, so what is going to happen? So we are going to see our next stroke, that is our expansion stroke, even it's called a power stroke. Now, because of a supplement of a spark, a sudden explosion of air and petrol mixture will take place within a cylinder. Because of that, hot gases will be generated, and that hot gases will exert its pressure on a piston, as a result of which piston will move in a downward direction from a top dead center towards the bottom dead center with a high speed, and suddenly a fluctuation in speed will take place. Okay. So this speed is very much higher, that if this speed is directly supplied to our wheels, then suddenly the speed of vehicle can be increased. Okay, fluctuation of a speed can take place. So for this purpose, we are going to provide a flywheel on a crankshaft which is going to operate on a concept of inertia, which means during a power stroke, whatever additional mechanical power is generated is stored by a flywheel by means of its rotational motion. That is, continuously it is going to rotate at that speed and will maintain a constant average speed of a crankshaft. So during this power stroke, flywheel will store the additional energy and will release or will supply this stored energy during the remaining stroke, that is exhaust stroke, suction stroke and compression stroke. Okay, now next, there is a last stroke will be an exhaust stroke. So we can say that at the end of power stroke, piston will have arrived at its BDC position. Now hot gases are present in a cylinder, and again for performing a next cycle, suction has to take place, which means air and petrol mixture has to be entered into a cylinder. But hot gases are present in a cylinder, so we need to reject that hot gases to the surrounding atmosphere. So the last stroke will be an exhaust stroke, in which piston will move from its bottom dead center towards the TDC side. Inlet valve will remain closed, but during this stroke, exhaust valve will be open and hot gases will begin to exit the cylinder through the silencer into a surrounding atmosphere, and hence a cycle is completed. And how much revolution crank has performed? So we would say that during suction, half revolution, during compression, another half revolution. So in two stroke, 1 revolution, in another power stroke, half revolution, in exhaust stroke, half revolution, which means another 1 revolution. So total 2 revolutions of a crank has been done to perform 1 cycle of our petrol engine. Okay, so this is how a 4-stroke petrol engine is going to operate. Similar is the operation with a 4-stroke diesel engine. The only difference will be that in a 4-stroke diesel engine, we are going to make use of injector. Okay, and during suction only air is going to enter into a cylinder. So let's see that. So our next topic, 4-stroke diesel engine. Okay, so the diagram of 4-stroke diesel engine is displayed on your screen. You can see that in place of a spark plug, I have written fuel injector. Okay, so this is the main difference. And there is no carburetor which will be used in a diesel engine, because as we know that carburetor purpose is to mix air and petrol mixture. But there is no requirement or there is no need to mix air and diesel. So there is no carburetor in this engine, remember. But there is a fuel pump which is used in this engine, which is going to provide a pressurized diesel fuel to a fuel injector. And the purpose of fuel injector is to spray diesel fuel into a cylinder in form of fine atomized form, which means much tiny particles, so that more contact surface area will be provided and evenly diesel can be mixed with air. Okay, so what I am telling you will understand after seeing all these strokes. So let's begin with the introduction. Now diesel cycle was developed by German engineer Dr. Rudolf Diesel in the year 1892. Okay, again this cycle comprises of a 4-stroke, that is suction stroke, compression stroke, power stroke and exhaust stroke. Okay, now let's begin with our first stroke, that is called a suction stroke. So the working is going to remain same. During a suction stroke, piston will move from its top dead center towards the bottom dead center. At that time, because of a cam mechanism, remember, because of cam mechanism, inlet valve will open. Cam is going to strike the inlet valve at that time. Okay, inlet valve will open. Due to pressure difference, only air will enter into a cylinder. Okay, so due to pressure difference, air is going to enter into a cylinder. Crank will move from its 0 degree to 180 degree position. When a piston reaches its BDC position, completely air will be filled in a cylinder. Inlet valve will be closed now. Okay, now the next stroke will be our compression stroke. So let's see it. In a compression stroke, what is going to happen? So during this stroke, piston is going to move from its bottom dead center position towards the top dead center position. Both the valves are going to remain closed during this stroke. Now, due to the movement of a piston, air will be compressed, its pressure is going to be increased, its temperature will increase, its volume will be reduced. And finally, after compression, the highly compressed air will be present in a clearance valve. Now, the actual part comes over here. can I say that in this cycle we are compressing only air, that is a single fluid, whereas in our petrol engine we were compressing mixture of air and petrol, right? So in which case compression will be higher? In a two-phase mixture, that is in our petrol engine or in our diesel engine, in which only air is going to compress. So we would say that in a diesel engine compression will be much higher. Why? Because density of air is much lower, that is nearly 1.25 kg per meter cube, and we are only compressing air, which is a compressible fluid. So higher compression means higher will be a temperature and pressure of air at the end of compression. And if it's so, then we would say when diesel is injected at the end of compression, the temperature of air will be much higher than the self-ignition temperature of a diesel fuel. So, diesel fuel will be ignited by itself as soon as it is sprayed into a cylinder by means of fuel injector. So, let's see our next stroke, that is our expansion stroke, that is power stroke. So during this stroke, inlet valve and exhaust valve are going to remain closed, but due to fuel injection, tiny particles of diesel will mixed evenly with particles of air which are at a high temperature. Remember, as soon as it mixes with air, a sudden explosion automatically takes place of a diesel fuel and a power stroke is generated, hot gases are formed. These hot gases are going to exert pressure on a piston. Because of that, what is going to happen? With a high force, piston will move in a downward direction, that is from a TDC side towards a BDC side. Power stroke will be performed. Again, a fluctuation in speed will take place during this stroke. So a flywheel will come in this picture. What is going to happen? So during this stroke, because of more energy, flywheel will store additional energy and will supply a remaining energy during our remaining stroke. So power stroke is performed. Finally, piston will come at its BDC position. Whatever hot gases are present in a cylinder, now it has to be rejected to the surrounding atmosphere, right? So in the next stroke, that is our exhaust stroke, piston will move from a BDC side towards a TDC side. Inlet valve will remain closed, but exhaust valve will open, and due to the motion of a piston, whatever hot gases are present in the cylinder will start to get out from the cylinder through the silencer, finally into the surrounding atmosphere. And at the end of this stroke, our cycle gets completed, and again next cycle repeats. Okay, so this is how 4-stroke diesel engine is going to operate. So in this case, you have to remember that diesel is ignited by itself, that is a self-ignition takes place. So it is even called as a compression ignition engine. Why? Because at the end of compression, diesel is self-ignited. Okay, so remember another name of this cycle, this engine is compression ignition engine. Okay, now let's proceed further. Next we need to see comparison between spark ignition engine, that is our petrol engine, and compression ignition engine, that is our diesel engine. So let's see. The first difference is very simple. It is based on a thermodynamic cycle. That is who has introduced the concept. So SI engine, that is petrol engine, was developed by Nicholas Otto. So we would say it is based on an Otto cycle, whereas CI engine was developed by Dr. Rudolf Diesel. So it is based on a diesel cycle. Second point, it is based on a type of a fuel used. So we would say that petrol is used, whereas in a diesel engine, that is CI engine, diesel is used. Now talking about compression ratio. So as we know that compression of air and petrol is lower compared to compression of air in case of CI engine, that is diesel engine, right? High compression takes place of air in CI engine, whereas low compression is taking place in a petrol engine. So compression ratio will be lower in SI engine, which is ranging from 5 to 9, whereas in case of a CI engine, it is ranging from 14 to 20. Now taking a case of a cost. So initial investment will be higher in which case? So in case of diesel engine, initial investment will be higher. So as we know that diesel cars are costlier. Why? The reason is that diesel engine has to withstand high temperature, as we are only compressing air, and because of that, temperature of cylinder and piston will be much higher at the end of compression. So thickness of cylinder, thickness of piston is going to increase, and because of that the overall cost of engine is going to increase. So the diesel cars are much more costlier compared to petrol cars. So we can say that low initial investment in case of petrol engine, whereas high initial cost in case of diesel engine. Now taking a case of a weight, so which engine will be heavier in weight? So it is very obvious, since thickness of cylinder and piston are increased, so we would say diesel engine will be heavier in weight compared to petrol engine. Next point is based on thermal efficiency. So thermal efficiency means in which engine heat energy evolved is higher. So we would say in diesel engine heat evolved is much higher. The reason is that we know that we are injecting diesel at the end of compression stroke, so it is easily mixed, evenly mixed. Why? Because it is injected in form of a spray, so evenly it gets mixed, and because of that unburned portion of diesel will be much lesser compared to petrol in case of a petrol engine. So large amount of heat energy can be released in case of diesel engine compared to petrol engine. So because of that we can say that SI engine, that is petrol engine, has a low thermal efficiency, whereas diesel engine has a high thermal efficiency. Taking a case of a speed, so high speed engine is SI engine due to its lighter weight, whereas CI engine is a low speed engine because of heavier in weight. Now next is based on how we are going to ignite the fuel. So we know that in petrol engine, that is SI engine, we are igniting fuel by means of a spark plug, so we would say it is a spark ignition engine. And in case of CI engine, it is self ignition, right? It is ignited by itself at the end of compression stroke. Okay guys, so I hope that you are clear with the 4-stroke petrol engine, 4-stroke diesel engine and comparison between both of them. So in today's session we are keeping up till here. In our next session we will study 2-stroke petrol engine and 2-stroke diesel engine. Till then, stay tuned and thank you all.